So why do we flip the inequality symbol when multiplying or dividing by a negative? My students know I don't like just to teach rules that they will soon forget. I like to teach them the why so that they can figure it out for themselves long after they forget the rules. So let's do some investigating here. So if we have, let's take something that we all know. We know that 3 is less than, let's say 5, right? 3 is less than 5. We know that because it's to the left of 5 on a number line, okay? So if I multiplied both sides by 2, I will get 6 is less than 10. That's also true, okay? I could divide both sides by 2. Let's take 3 is less than 5 and then divide both sides by 2. So we'll get 1.5 is less than 2.5. So I've done things to both sides and it worked out, and it's the same. It's still an equal statement, a true statement, not equal, true statement, right? Well, let's see what happens if I multiply by a negative number. So let's, instead of multiplying by a positive 2, let's multiply by negative 2. So 3 times negative 2 is negative 6, and 5 times negative 2 is negative 10. Well, if my number line extended, you'll see that negative 10 is over here, and negative 6 is right here. So which one is smaller? Negative 10 is smaller than negative 6. Do you see how we have to flip the inequality symbol when we multiply by a negative? Let's take dividing by a negative. Let's say 2 is less than 6, and that's a true statement, right? We know 2 is less than 6, so let's divide both of those by negative 2. 2 divided by negative 2 is negative 1. 6 divided by negative 2 is negative 3. And what do we know about negative 3 and negative 1? Negative 3 is smaller than negative 1. Okay, we know that when you're doing negatives, it's weird because you're negative 3 in our brains. I think we want to think that negative 3 is bigger because 3 is bigger than 1. But if you think of debt, I would rather owe someone $1 than owe someone $3. So negative 1 is definitely bigger. And do you see how this just proves right away that we have to flip the symbol when we're dividing or multiplying by a negative? We have to keep it a true statement. And so what that looks like, your problems aren't going to look like that. They're going to look more like negative 3x is less than 9. And then you have to divide both sides by negative 3, and then you flip the symbol. Instead of a less than, it's a greater than, and it becomes x is greater than negative 3. So if you ever want to prove it, you just plug in these fake numbers here. Why did I pick 3 and 5? Just because I did. They're just random numbers that I picked. So you can always prove these theories instead of just, listening to your teacher and memorizing the rule. You can prove it yourself. So, all right, I hope that helps.